So welcome back, and the next session will be our guest faculty, Dr. Gerfred, and welcome for this lecture, Dr. Gerfred, and it will be on facts, figures, and integration of biorefineries in a future economy. So the figures, I think they are most important. Without that, anything is futile. So let's welcome our guest faculty for the next lecture, please.
Okay, good morning again. The lecture today will be the last lecture before I also step into LCA. It's still on the technical side, a systematic how to describe biorefineries, because the most important thing is before you start doing an LCA, you have to understand the system, what's going in, what's happening inside, and what's coming out, at least, and this is part of a biorefinery we learned already yesterday. And this term of bioeconomy means the overall economy, you understand, yeah, and the bioeconomy is the part that uses biological resources, yeah, to be processed to food, feed, biofuels, chemicals, or whatever. This is the idea, and we have seen that picture already yesterday, where we've seen that we need this integrated approach, because if we use biomass, you cannot only produce biofuels. Yeah, you always have other products within the process occurring up. And the principal definition developed by the International Energy Agency was biorefining is the sustainable processing of biomass into a spectrum of marketable products. And spectrum really means you have more than one product. And all the products must be marketable. So you need a market to sell the products. Because if you make products, if they're too expensive or have properties nobody needs, really you have to address products that you can sell on the market. And the biorefinery, as I mentioned yesterday already, is somehow similar to what's happening in oil refinery, because also in an oil refinery you have a broad spectrum of different products, clearly a strong focus on energy carriers, but also raw materials for the chemical industry. And the same thing you can do also with the biomass by different conversion processes to also uh, produce amounts of energy carrier, but also many different chemical products that can also replace step by step, maybe in future, the oil-based materials. And at least what we see today is we have at least two different kind of motivations to go into a biorefinery. One is more concentrating on the product, on the chemical. For example, the pulp and paper industry, it's also a biorefinery. Yeah? They also produce electricity and heat in surplus, but their main focus is really a product, to make pulp, to make paper. On the other hand, we have a strong focus, for example, for bioethanol, biofuels in general, where you say, I want to produce big amounts of energy carriers. Yeah, so the bioenergy product is in foreground, that key motivation. But as we know, you always co-produce other products. And economically, it looks somehow like this. On one hand, it's a question on the volumes you produce. And on the other hand, it's a question, what is the market price you get per ton or per volume? Yeah? And normally the biochemicals, the biomaterials, they have a higher price per ton. Pharmaceuticals even have a much higher price here than the energy carrier. So the energy carrier's price per ton is relatively low. So to make a reasonable overall economic framework, you need big amounts of transportation fuels. They could be liquid or gaseous, yeah, because the market price is lower, or you concentrate more on high pricing, low volume materials, chemicals, or even pharmaceuticals. So this is at least the trade-off you have to make and design and think about developing a biorefinery. And at least you will see later on there are so many different types of of biorefinery. And we talked already yesterday when we talked about biofuels, you have to know the feedstock, you have to know the specific biofuel, and you have to know the process, the conversion process. And at least these three elements, of course, also appear in describing the biorefinery, the product, the feedstocks, and the processes. There's only one additional feature that is also relevant to describe a biorefinery, and this is the platform. The platform on the next slide, I explain more. It's more or less on the way towards your final product. You have different platforms. Sugar is a very good example. We've seen that sugar can be made from different sources, but when you have sugar, they can be fed from different sources, but then you go to fermentation with the different sugars. So the sugar is a typical platform, yeah, for the area you are experienced in. And with these four features, you're really able to describe all the different biorefineries. That's the nice thing. Even if biorefineries on the first glance look maybe complex, yeah. But anyway, it's a relatively formal and easy, systematic with these four features: the platform, the product, the feedstocks, and the processes to describe different platforms. Um, so what describe different biorefineries? And within a biorefinery, the key element of this classification is really the platform. Um, you will see it could be an intermediate from raw material towards the final product. It could be an oil platform, a sugar platform. It could be a syngas platform. We've heard yesterday with the syngas with the carbon monoxide and hydrogen. You can make so many different things. So syngas is also a typical platform being fed maybe from different processes. It could also be a final product. Yeah, that of course you want to shell only sugar. You can take the sugar and shell it. And at least this is a key element in describing this, describing a biorefinery. And and when you use these four elements, you can set up a very generic system of a biorefinery. And the system starts at least with the feedstock on the top and with the products on the bottom. And the products we tend to divide between products for the energy market and products for the material for the chemical market. So this is a principal idea that you have two different markets. And then in between, you see a platform. You normally always have minimum one platform. And before and afterward, you have the different processes. We learned yesterday. You can have thermochemical processes, biochemical processes, or whatever. They converted it step by step. And by adding up these four features, you have the possibility to describe a biorefinery. A very easy example is here. If you want to make biodiesel, we've learned yesterday you always co-produce glycerin and feed. So you see glycerin and feed, and you see also at which processes these byproducts come up. Yeah, so you see the glycerin is coming from the esterification, and the animal feed is coming from the pressing step. Yeah, so you start with the oil crops on top. You have the pressing, you create the feed, then you go with the oil in the platform, and then the oil is esterification towards biodiesel, and you have the glycerin. So this is at least relatively. This is the system to describe somehow the insights of the different processes of a biorefinery. And and the nice thing, and on the other hand, also the complex thing is there are so many biorefineries around. Yeah, and here in the gray area, you see now step by step different biorefineries popping up because these biorefineries can also be linked. Yeah? So if they have a common process or a common platform, yeah, so you can also link different biorefineries. And on the bottom, you always start with a raw material. Yeah? So this is a typical conventional bioethanol production from starch crops via sugars, via fermentation to ethanol and animal feed. Yeah? So this is one typical biorefinery. Another one is the biodiesel chain, and you see the biorefinery for biodiesel and for bioethanol, they have nothing in common on that. Yeah, so they're really separated. They have no common platform, no common processes. Even if you make biogas from organic residues, it's also they are quite separated. But additionally, when you look on the on the lignocellulosic gasification, it's also at this step a single one. Yeah? So already here you see 4 different biorefineries, different feedstocks, different product, and they have so far nothing in common if you look on the syngas platform, but you can make the C6 sugars not only from the starch crops, you can also make them from lignocellulosic residues. Yeah? So already this refinery has a common platform on the C6 sugars. Yeah, there's one possibility to say the C6 sugars are at least a possible combination of 2 biorefineries. The interesting thing is if you start with a conventional bioethanol facility, yeah, you can in future further develop that to additional feedstocks, yeah, because if you have additional feedstocks, you can produce additional sugars and can use existing infrastructure. The most difficult thing is really to start first on a green field to build up something, yeah. But then, of course, it's more feasible and economic possible if you can really integrate it in the existing infrastructure. And this is at least something for these different biorefineries. So you see, it's a very colorful picture. Yeah, just to describe, there are so many ways from biomass to different products, and in all the LCA, you really have to be clear in describing the system you mean, and say this is my system. That's what going in, and that's what coming out. We try to we put in the last years much effort on these different biorefinery concepts, and we're trying to identify more and more of these biorefineries. Most of them, or I would say all of them, you see it's highlighted here, they have a strong focus on biofuel production. Yeah, producing high volumes or big volumes of biofuels, and the side products are more or less the chemicals or the animal feed are more a byproduct, but still very relevant to reach an overall sustainable and high efficient system. The naming is at least the naming that's also somehow normalized. You say you start with a number of platforms, and simply you can say the more platforms you have, the more complex the system is. Yeah, so you see 1 platform, 2 platforms, 3, 4, even 5 platforms. That's really a relatively complex system. So at least a number of platforms give you already an indication how complicated and how many processes are involved in the system. And with out of these biorefineries, you can create the different pictures following still these 4 features, starting with the raw materials. Here we have sugar and starch crops. At least they end up in the sugar platform from where you can produce the bioethanol, and 2 different types of feed might occur if you use different feedstocks. Very important in this graph is also all these processes, they need energy. They need steam or heat, and they need electricity. And it's always a question, where is heat and electricity coming from? And therefore, it's also important to see in this graph somehow the platform of heat electricity. And you see, here are other sources used. For conventional ethanol plants, I already mentioned yesterday, in Europe, they mainly use grid electricity and natural gas. Yeah? So and the grid electricity and natural gas is not linked to the raw materials. In some biorefineries, for example, if you use wood and straw, you can use the lignin to make electricity and heat and power the system. And that you will also see then the electricity and heat is somehow connected to the raw materials we use. But in this case, it's clear it's totally separated. So you will understand this is relevant, that external resources are needed for energy production. This is a concept where we have more integrated. This is making bioethanol mainly from wood chips, and depending on the different combinations and the pre-treatments, you have different products in between. We see here again that the sugar platform and the lignin platform. In this specific case, we also convert the lignin further on to phenols. This was within a project we did with the particle board industry. This is a typical particle board. Yeah. and to glue the wood together, you need phenol-based resins. Yeah, and this is one possibility to use the lignin via pyrolysis. It's not an easy process. It's not economic today, but it's somehow interesting to use to make the phenols, and all the remaining parts you can burn to make electricity and heat. And in this example, you see that the electricity and heat, at least the raw material, is coming from the wood chip. So it's totally integrated. Yeah? So also electricity and heat is made from the feedstock. And if you have more electricity and heat than you can use in the facility, of course, you also can sell electricity and heat for outside. This really depends on the overall refinery, how much heat and electricity you need. If you have addition and you have electricity is easy, you feed it in the grid. For the heat, you need somehow a district or a nearby other industry. But anyway, this says that also here electricity and heat might be a product of this refinery. Yeah? And the pictures get even more colorful. This is a combination of bioethanol production from conventional feedstock, for example, starch crops, and straw. Because if you grow starch crops, you always have the straw on the field. Yeah? So at least you have both. And if you have the possibility also to bring the straw there and the technology to make sugars out of it, and you can ferment it, of course, that's a good way. Again, the lignin from the straw can be used to provide electricity and heat. Yeah, so you have also electricity and heat coming at least from the straw. And additionally, in that case, it's a little bit even more sophisticated, but we first gasify the lignin to have a syngas to also produce a Fischer-Tropsch biofuel, which has mainly a diesel quality. The reason for this, the interesting on this concept is that in this concept you make a gasoline substitute, the bioethanol, and you make a diesel substitute for the fossil diesel, like an oil refinery, because you need both. I don't know the share in India between gasoline and diesel. In Europe, it's nearly 50-50. So that also, but here you have a certain flexibility to cover the market demand by offering both products for the transportation sector. And of course, the Fischer-Tropsch biofuel can be also an aviation fuel for airplanes in future. So this is also one possibility in future. And this is another highly integrated biorefinery. This is at least attached to a pulp mill, because the pulp mill already uses big amounts of wood. Yeah? So this is a good starting point to also make bioethanol. I told you yesterday that already in Austria we have one pulp and paper mill fermenting the sugars in the liquor, in the black liquor, to bioethanol. But additionally, if you have wood chips or sawmill residues additionally in that refinery, in that pulp and paper mill, you can also create additional sugars to make bigger amounts of bioethanol. And this is something we are considering very much in Austria and also in Europe, to say if we have places already where biorefineries are existing and working, like in a pulp mill, it's a convenient place to further extend. Yeah? If you have additional wood there and you make further amounts of bioethanol, this is an optimal place to step by step develop this concept compared to really start on a green field by developing everything you need. And so for this is at least still relying on these four features of describing a biorefinery: the feedstock, the platform, the processes, and the products. That's at least the whole story. We are somehow proud on this classification scheme, because I developed that I think 15 or 20 years ago with a PhD student from Italy, because at this time there was no clear classification, and together with him we developed this classification system, published a paper, and it's in Europe it's widely used, especially the Germans took that in a German norm of describing biorefineries, and that is really a good thing, because of all the different biorefineries you see here, you have to really need a clear description what biorefinery you're talking about. And when you see a result of an LCA, you have to know what is the basic biorefinery behind it, yeah? Because if it's a different concept, of course the LCA results are different. Yeah? So this is very important to to understand this. But once you have defined your biorefinery, you will see you need some basic information on this biorefinery. And life cycle assessment always starts with a technology description. So your background here is perfect because you have a technical natural based background. Yeah, you know what is a mass balance, you know what is an energy balance, and this is at least very important to understand this concept. And we have developed a brief concept to really communicate the key facts and figures if you're going to describe a biorefinery. And we have developed this also in collaboration with the International Energy Agency. There's a task, we call it task activities, task 42. You can also Google it, it's on biorefining. And it was really to structure the discussion by a harmonized approach to describe the different biorefinery concepts. There are many countries involved in this activity, and we have developed a so-called biorefinery fact sheet. Yeah? And fact really means technical data, because LCA is always starting with technical data. And we have two parts here. The first part, A, is describing the biorefinery. And the part B gives you some key information about the value chain. Yeah, we heard about value chain already yesterday, and the part B here gives you the value chain assessment. And in an annex, you find the details, what are the background data to describe these biorefineries. The thing is relatively simple because it's just a 4-pager. Yeah? So the idea is really to condensate on 4 pages the key elements, and people that are used to tables and diagrams, it's the best way to communicate, not reading long lectures and text. It's at least to have a graphical information to really see on one glance what is the biorefinery concept here. Yeah, you see here again this classification scheme and information about the mass and energy balance. I will zoom in there. And on the second part is the value chain assessment. And the value chain assessment has at least 2 parts. One is an economic part to get a clue what are the investment costs, what are the costs for operation, and so on. And the other one is already an LCA by comparing your biorefinery to a reference system. And as we know, is if you have an LCA ending up just with one number, yeah. This morning we heard a different way where you can compare it to the overall effect and see how much you add to this effect. In this comparison, you just compare it to another system providing the same services, the same product, and in comparing these products, you see if your biorefinery concept really is significantly more sustainable than the reference system. So this is what we are aiming for. So these other 2 pages, 3 and 4, they are dedicated to give you the information about key data on this value chain assessment. So I zoom in now a little bit in part A. At least the idea is to describe the mass and the energy balance. And because you have to know what's going in, what is the input and what is the output, and most important, what is lost. In biorefineries, you normally lose water from the feedstock. You might lose oxygen because it's integrated there. However, to really see how much mass is going in and what is coming out. And it does not mean if you have a low or high mass conversion rate, if it's good or bad. It's just to describe what is going in and what is going out. And the same thing is also with the energy, to see how much energy is going in with the feedstock, how much energy do you need for the electricity and the heat or the chemicals, and what is the energy content in your different products here. It's just one example of a case study we did in cooperation with a company. They have developed a process that can be integrated in an oil refinery by making pyrolysis oil. Yeah, pyrolysis is more or less melted wood. It has still water and oxygen in it, but it's a process that is able to be integrated somehow in the conventional oil refinery by making at least the products greener. Yeah, so this is just one example. It's not relevant here, but to give you this addition. But Here you have the main information about the mass balance, and you also get an idea about the costs. Yeah, so the money you have to spend to run the facility, and normally the feedstock, the raw material, is normally half the cost, or even more, or a little bit less. But still, all the refineries, they need feedstock, and the feedstock cost is economically very relevant. To have it available, of course, but also the price, and then the capital costs, and the rest are the operating costs on an annual basis that are relevant. And of course, in ideal case, the cost and the revenues are equal, or the revenues should be higher. But on the other hand, you also see when you sell these four products on the market, yeah, they have a different price, you have different volumes. So how much money do you get as a revenue from, in this case, four different products? Yeah? And you see here, I would say you have two bigger products giving you higher revenue, and two lower ones, but it's relatively good distributed. And of course, you need a market for this product. And this is just to have an idea, because if you have only two products and one product gives you 90% of the revenue, you know, that's a tricky thing, because if the market price is decreasing and you rely to 90% on selling one product for a certain price, economy is much more difficult if you have a broader portfolio of products, yeah, and serve different markets. So you have a little bit more flexibility, and can be more sure that the overall system will work economically. And then in the second part, we do this value chain assessment. So this is already a step towards life cycle assessment. And in the left hand side, you see again the process chain, from the raw material to the final product, And you start here in that case by collecting the forest residues. You have to transport them to the biorefinery, and in the biorefinery, you make these four different products: a diesel, a gasoline, a biochar, and this pyrolysis oil. Um, at least they have to be distributed and have to be brought on the market to be used. So the use here, if you have a gasoline and you put it in a vehicle, of course, the product is a transportation sector service. And then we have to compare it to something. Yeah? And in that case, we compare it to an oil-based refinery, at least starting with a fossil resource, with the extraction of raw oil that also had to be transported to a refinery. And in the refinery, you produce diesel and gasoline and heating oil in that case, because the heating oil is replacing the pyrolysis oil. The diesel gasoline are replacing the renewable diesel and gasoline. And we have biochar on the left hand side. So we also need a replacement for the biochar. And in that case, we also took fossil-based char to have the same services. And this is a tricky thing. We already heard this morning, and you will also learn it the next day, what is really the same product on both sides, because you need the same service, the same quantity, the same quality on both sides to really make the systems comparable. Yeah? If you have one product more on one side than on the other side, you cannot compare it. And this is really a tricky thing, and there are some ways to handle that. Of course, we can handle that. And in that case, the product service is, at least you can imagine, like going shopping. You have a shopping basket where you have different things in, and you get these four products from the left hand side and the right hand side. So at least in your product basket or shopping basket, if you have the same products with the same opportunities and things, and usage cases, then you really can compare both sides. Um, um, make a step in between. It's always a big question: what is the conventional system you're going to compare? Because depending on what you define here, I go back again. What you define here on the right hand side, yeah. If you make another reference system, you might have another result. Yeah. So it's really a tricky thing to also define what are your conventional systems for comparison. So on one hand, you have the biorefinery system providing you bioenergy and biomaterial, and you can say, on the other hand, you have a pure 100% based fossil system where everything is coming from fossil energy. This is one reference, and of course then you get a certain difference. But in between, you could also define that maybe you have already an existing biorefinery which does not produce all the product services you need. Yeah, so you have a combination in between of an existing biorefinery and an existing fossil resource. Yeah, so in between you have a mixture of using bio raw materials, biogenic raw materials, and fossil raw materials, which can also be defined as a reference case. So if you compare the biorefinery now to the middle system, of course you get different results compared to the fossil system. So anytime you have a result of an LCA comparing something, for you it's also important to see what is the system it is compared to. Yeah, and that is something that is also relevant. And defining what is the reference system has many different background decisions that are necessary to really decide. The easiest way is really to think what is the existing system you're going to substitute. Yeah, so if you really substitute fossil-based gasoline with bioethanol, if that is really the intention of your biorefinery, then it's the easiest way. If you're producing products that are maybe new products, it becomes even more difficult. Okay, coming back to our value chain assessment, to the result, and in that assessment based on LCA, we have here on one hand the primary energy demand, or called cumulated total energy demand, for this biorefinery with the big green part, and the reference system, which is the fossil refinery with the black part. In total, they roughly need the same amount of energy for the same type of product, but the big difference is in one case, the big part is coming from biomass, so it's renewable one, whereas in the fossil case, the main part is coming from fossil energy. In all the systems, you always have other renewables or other sources integrated because they all need different energy inputs or materials, and they somewhere have hydropower, wind power, nuclear power, or whatever included. So that's why you always have this red part more or less covering other primary energy carriers. But the big advantage is, on the other hand, if you see the greenhouse gas emissions per year, yeah, so this is a value per year, you see that the biorefinery system has significantly lower greenhouse gases by providing the same service compared to the reference system. Yeah, and this is the important thing. So on an annual basis, you can say the system really has 80% less greenhouse gas emissions compared to reference system. Yeah, same energy input, different shares of energy, and at least an output, a reduction on greenhouse gases. So this is at least the key elements, first describing the biorefinery, then defining the reference system, and then ending up at least with a consideration, environmental consideration on greenhouse gases and primary energy. That's at least a minimum information from life cycle assessment. You expect getting information about the energy efficiency and getting information about greenhouse gas emissions. And then you can enter all the other impact categories. We've heard already this morning, and we will learn additionally. And finally, I show you now, if we have these different biorefineries and we want to develop this bioeconomy, it's a question: how can you integrate different biorefineries into an existing infrastructure? And you see here the map of Austria. We are located here, so we come from Graz. Yeah. Here's Graz, so we're very close to the Slovenian and the Hungarian border. It's the second biggest city in Austria, but we have only 250,000 inhabitants. Vienna is having 2 million, and all over Austria we have 8.5 million inhabitants. Yeah, so it's a little country compared to here. But here you see the existing infrastructure. We have an existing infrastructure, and if we want to develop biorefineries step by step, we have to think, what is the best way to integrate that into the existing infrastructure. And and what we do here, we start first to classify the existing industrial infrastructure, because a biorefinery in most of the cases is an industrial facility. Yeah. So if you can use already existing industries, existing industrial facilities, so at least we look on these 10 different system sectors that are somehow relevant or a connection point for biorefineries. You see here oil refineries, of course. You see existing biomethane or biogas plants, biofuel plants. So they are all possibilities to describe them. And in the first step, we define these industry sectors, and we can also classify them like we do classify biorefineries. Yeah. So if they use wood, we say, okay, they use wood. Do they already use one of the platforms, one of the products or processes? Yeah? So these are all points where we can connect and integrate biorefineries. Yeah. So if we analyze now the existing infrastructure, with the same elements, from the biorefinery, we see where they match the most. And so we looked on the different industry sectors. We know in the pulp and paper mill what is the raw material, what are the products, what are their key inputs, and some of them. And then you also see the numbers here describing how many pulp mills do we have, how many biofuel plants, because the more we have, the easier it is. In some cases, if we have only one facility, we only have one oil refinery in Austria. Yeah? So it's only one. If we want to integrate it there, we have only one possibilities. Whereas for other facilities, pulp mills, we have 10 pulp mills. You have 10 possibilities maybe to integrate one biorefinery in that pulp mill. And what we do is, at least we see now how much the existing infrastructures, the four features, meet the four features of the biorefinery. Yeah, so we have the biorefineries, we have the existing infrastructure, and we see how much they have in common. Yeah, that's a relatively simple way, and this is a way then to see what are the best places and to really develop together with the existing infrastructure, with the existing industry, this biorefining concept. As you've seen before in this fact sheet, this example of including wood and pyrolysis oil in oil refinery, for example, yeah, is identified here on that map, and this is one possibility to integrate that. And of course, the more you have common features, yeah, the easier the integration is. This is the idea behind that. And we've also seen that the integration on the feedstock and product level is the most relevant one. Yeah? Because if you have already an infrastructure of bringing in raw materials, big amounts of wood, big amounts of grain, of raw material to a certain place, to a pulp mill, it's easier to further increase the raw material input, yeah, than starting with some new feedstock. So we've seen, and on the other hand, on the product side, if you have an existing product mix that already addresses a market, yeah, and if you know the market and you now come with a bio-based product fulfilling or supplying the same market, that's much easier than if you don't have yet a market access with your product and you need to find clients that want your product. So we've seen that the feedstock side in the very beginning and the product side are the key elements to be successful. Secondly, the platforms are somehow relevant, especially in the bioethanol sector, the sugar platforms, and the processes are maybe not so relevant. And when you do this example, we have identified these 10 industry sectors, and we have defined 15 different biofuel-driven biorefineries to see how this system works. And we've seen that these 14 biorefineries can be integrated in 31 different industry sectors. Yeah, and at least what we do at our institute, we are addressing these sectors and trying to explain them. There further possibilities in developing this bioeconomy, in establishing a biorefinery integrated in their production process, and this is at least a possibility to identify which refineries suit best in which sectors. And as I've mentioned, Austria is a very forest-rich country. So we have much pulp and paper industry, we have much wood industry. So for us, forestry is a very good domestic resource. So in that analysis, it came out that the pulp and paper industry, for these concepts we were analyzing, were really most attractive and interesting, because they really match many of these features. So on our pulp and paper industry, they're really going towards more and more biorefining, making more than only pulp and paper. Maybe in future they will make more biofuels, but also maybe more bioplastic, because this is really an upcoming attractive area to use raw materials based on biomass to substitute fossil-based products. So this was the story of upgrading, we call it upgrading strategies of existing infrastructures towards the bioeconomy. And the term bioeconomy, I don't know if you use it also here in India. In Europe, it's very common to talk about the economic sector that uses biomass. It's also including the food and feed industry. We call that bioeconomy. And we have an interesting discussion also going on if on the long-term run everything will be bioeconomy. If it would be possible to provide all the services only based on renewable and bio-based materials or not. Maybe that is a good discussion point for a morning walk or a dinner walk also with you, to see if there's somehow limits. I have a clear opinion on that, but I would be interested in how you feel. But at least it's called the bioeconomy. So this is my final slide. I always try to summarize the key points in a so-called take-home message. We've learned here that biorefinery is the sustainable processing of biomass into a spectrum of marketable product, really marketable product, and the less on residues or waste with no value you create, of course, the better is. We've seen these two different motivations of making a biorefinery. One is bioenergy driven, where the big volumes, mainly transportation fuel, is the key product you're trying to sell on the market. Whereas the bioproduct driven, it's mainly the pulp and paper industry is a very good example. They want to sell pulp, they want to sell paper, and additionally also energy carrier. It's interesting to see that the pulp normally was only used in wood, in paper, and now they also go much with this pulp into the textile sector, because the pulp and paper market is a little bit decreasing, and pulp has many possibilities also in the textile sector. So it's a wood-based textile you can wear. Most of the time you don't know it. So this is a typical bioproduct-driven biorefinery. Then we have seen these 4 features to classify a biorefinery, but the key element is really this platform. This platform as an intermediate. Sugar is, I think, the best example for you to understand the different sources to make sugar, but the fermentation is a common thing. Then we have the product as a feature, the feedstock, of course, and the process. And with these 4 elements, you can build up this process chain. It's really a way to describe clearly what is the biorefinery you are analyzing and you are addressed. And we've also seen this biorefinery to collect key data, key information. Beside this classification scheme, we need a rough idea on the energy and the mass balance. So how much feedstock is going in and how much of the mass is really ending up in product, or what is converted to CO2 to make electricity and heat. But this is basic to know what's going in and going out. The same with the money. So what is the money I have to spend? What are the costs? And on the other hand, what are the revenues? What is the money I earn when I sell my products? Of course, you can understand normally the revenue should be higher than the costs in ideal cases, or even much higher. But anyway, this is just to get an idea what is the key economic framework conditions. And then, of course, to build up this value chain assessment, defining a reference case that you can use to compare it to the greenhouse gas emissions or the primary energy, really to compare it to a so-called reference system. And finally, I've shown you one example that this biorefineries can be integrated into existing industrial infrastructure. It's again the 4 features that help you to find places in existing industrial infrastructure to develop or attach or further make a biorefinery. So this was my summary for this morning lecture. And if you have any question, you can ask me now or later during the day. So everything was clear.
So thank you for nice lecture, and it was looking very complicated, but the way you have presented those complex figures and how they are interrelated, it was wonderful, and thank you for that. So you have been associated with many agencies and many policy making and decision making agencies. So how finally we come to a conclusion whether to adopt a technology or not? Is it solely based on environmental impact assessment, or the financial gains which country or industry is getting? So how do we strike out a balance?
Yeah, that's a very important question. And I would say it's a stepwise approach. First, you really need the technology. Yeah, so at least if you don't have a technology to do something, yeah, so really you need a technology. You have to develop it first in laboratory, pilot, and demo scale, and then maybe the first commercial thing. So this is the starting point. It must be technically feasible. And secondly, even if it works on a technical basis, it must show a certain business perspective. Yeah. So if you're making nice products out of lignin, they are nice, but they are so expensive because the processing is so complex. Yeah. So at least the second thing is really to find business opportunities. Yeah. Even of course in the beginning you can include subsidies or whatever from the public side, but at least you need a really clear business idea. And this depends on many framework conditions. Yeah. And uh, also ending up with financing possibilities, but also with others. And should you start with a small system, a small biorefinery, or already make a bigger one? These are very complex things. Yeah? But at least you need a clear economic perspective, and you need the stakeholders. Yeah, so the industry. Yeah, I would say as an example, the pulp and paper industry in the past they have been very traditional thinking because the pulp and paper business was doing well, so they had no pressure to do something else than just extending their production. But then the paper market went down, especially for newspapers and other. The paper went down, so they were thinking on new business opportunities. Yeah, and that's when they came and asked, what else can we do? And then we said, you can make biofuels because you have sugar in your black liquor, or you can buy additional wood and make a gasification. So it's really you need the stakeholders from industry and also a support from government and the general public to say this is towards more sustainable, this is towards greenhouse gas reduction. So it's both. It needs the people, the government, and the industry. And then at least it's up to LCA. If you have the technology, you have the economic perspective, you have the stakeholders, you have the first design of a plant, and then you make an LCA and saying, okay, we are saving 80% greenhouse gases. If you do this and this, maybe we can save 90%. If you don't do this and this, you only reduce it by 30%. Yeah. And this is again an information fed back, and they say, okay, we would like to save 90% greenhouse gases, but we need 2 very expensive additional processes or inputs we can afford economically at this time. So we have to start with a lower greenhouse gas reduction because we don't have the possibilities to integrate that. So LCA just gives them, shows them, is there a significant greenhouse gas reduction, a significant reduction of fossil energy input or other impacts? And then also identifying what you can, if you don't do that, maybe you have lower ones, or even you can further develop it. So, and this is at least how things in we have developed this, and this takes really time. It really takes time, and it really needs also a political framework. And for that, I would say in Europe we have a very good current political framework, which is Green Deal, where we have clear targets for greenhouse gas reduction, clear targets for circular economy, and really this is for the industry a driver because they are forced to do something, and this really speeds up the process of integrating new biorefineries, bioeconomy in the existing infrastructure.
Yeah, thank you. Then, we are basically discussing here about biofuel. So, especially in Europe scenario, what are your thoughts? Will it be, commercially viable at large scale? Maybe it is methane, or maybe it is bio 2G ethanol, or maybe some other kind of, say, produced from gasification and all those. So, will it be a reality in near future?
Um, yeah, I'm generally an optimist, knowing sometimes it takes longer, but I think the good ideas they will win in the very end. I would say in Europe, I would say that the conventional bioethanol and biodiesel, which are based on, we call them food crops now. Yeah, so the biofuels based on food crops because of the debate in the past. I would say they have reached the maximum more or less. There's even in the European regulation a limit of how much food-based biofuels you can put on the market, and the rest should come from new sources. Yeah, so it's really the new sources is mainly wood and straw, I would say. Yeah, so there's a strong effort really to use lignocellulosic material to extend this. We have some pilot facilities, one going the biochemical way, one are going the gasification way, and I can judge which of them is winning the game. I think both of them will be relevant. Yeah, and I would assume that we in Austria did much research, not so much on lignocellulosic bioethanol, but on gasification. So maybe I'm more in favor of thinking that maybe gasification will be a little bit quicker. But anyway, it's both of them really offer a broad portfolio of products, bio-based, and I think that would be in Europe the way forward. Yeah.
Thank you. Any question from participants?
Sir, first of all, thank you for this amazing lecture. Sir, as you discussed about a lot biorefinery, but my question is that for biorefinery, what are the disadvantages or causes on environment or humans?
Um, yeah, that's a good question. So, as I've mentioned, only because it's a natural resource, it does not say it's sustainable per se. Yeah. So I would say we will learn during the course, but a key element is really the feedstock production. Yeah, to really produce the feedstock, and normally you need relatively in most of the biorefineries, not all, biomethane and biodiesel are smaller facilities, but most of them really need big amounts of raw material. Yeah, so really you have to produce big amounts of raw material. You need a very good logistic to bring that to one point where the refinery is. And so at least the feedstock cultivation and the feedstock logistic and supply might harm the or is a relevant part in LCA, yeah, in most of the cases. And the second thing is really that the biorefinery itself, what is the energy and heat demand in total, and where is this energy and heat coming from? Yeah. So if you need natural gas to run the process, of course, then the natural gas has a strong influence. Yeah. So it's mainly the energy demand for the biorefinery, how much you need, and where is it coming from? Yeah. And if you need a coal-based electricity or if you have hydropower, this makes a big difference. And in your performance, you have to make sure that um, also the energy comes from a sustainable source. Yeah. So this is at least the main parts. And the last one is the use of the product, or at least the end of the life of the product. So what's happening with the product? Yeah, does it disappear somewhere uncontrolled, or do you collect it again and reuse or recycle and so on? So this is the use phase. But for the biorefinery itself, it's really the feedstock and the processing, mainly the energy demand. And sometimes the water demand could be an issue if you need cooling water or if you create sludges from wastewater treatment. So water, with biomass, you always get water. Yeah, so you have the water treatment, even in a conventional bioethanol facility, is an issue. I would say, as a mechanical engineer, we can manage that. Yeah, we can manage, we can clean it up, and we can recycle water, and a little bit is so. But water might be also an issue, especially in areas where you don't have so much water being available.
Thank you, sir.
So if no more question is there, we can wind up the session and we'll meet after lunch. So assemble here at 1:50.
Thank you.
Thank you. Thank you, Professor.